Welcome to Bosch's Virtual Training Labs, IP Basics for CCTV, Module 2, Network Devices and the OSI Model. The objective of this module is to look at the OSI model and how it relates to CCTV installations. We'll be looking at network devices, broadcast, unicast and multicast packets, TCP and UDP communications, as well as TCP ports and how we utilize them. The OSI model, or the Open Systems Interconnection Reference Model, is a set of 7 layers that define the different stages that data must go through to travel from one device to another over a network. As a CCTV integrator or technician, your main focus should be on the bottom 4 layers of the OSI model and how they relate to CCTV and IP video. The bottommost layer of the OSI model is the physical layer. This layer defines your media to include cards, cables, and the physical aspects of your network. It's also responsible for transmitting raw bits across your network. Hubs, or what is now referred to as multi-port repeaters, reside and work at the physical layer. They are broadcast devices with no intelligence. They have a max speed of 10 megabits per second, and when connected to a switch, usually work in half duplex mode. You should never use hubs in a CCTV environment. Let's take a look at an example of how a hub might react if I were to push video across it. Notice it's a broadcast device. It sends the video not to just one client, but to all clients on the network. The second layer of the OSI model is the data link layer. It is divided into 2 sublayers, the LLC, Logical Link Control Layer, and the MAC, Media Access Control Layer. The data link layer is responsible for physical addressing, and switches operate at this layer. I want you to notice the correlation between physical addressing and MAC. In our previous module, I stated that when we did an IP config all, we could see our physical address, or otherwise known as our media access control address. Layer 2 switches provide us communication based on MAC addresses. They build what is called a CAM table, a configurable addressable memory table. And with this information, they can build what is called a virtual circuit. An example of a virtual circuit is shown here. Workstation 1 can communicate to Workstation 8, while Workstation 4 communicates to Workstation 5. There's no interference between the 2 transmissions. Switches are intelligent devices. They can differentiate between a broadcast and a unicast packet. In this example, because the switch can read that it's a unicast packet, I have true host-to-host communication. There's no excess bandwidth utilization, and there's no rebroadcast of the transmission. Layer 2 switches should always be managed devices when you're dealing with video applications. It doesn't matter if your installation is 10 cameras or 800 cameras. Off-brands and inexpensive switches will always end up causing you problems. The third layer of the OSI model is the network layer. The network layer is responsible for routing and logical addressing. This is where IP, Internet Protocol, the IP of TCP IP, resides. This is also where routers function at. I want you to notice that multicast is also listed here. Multicast addressing is a network technology for the delivery of information to a group of destinations simultaneously. It was originally developed to work on routed networks, layer 3, for the use of multimedia and video. In essence, multicast is a hybrid of unicast and broadcast. Here we see a unicast packet with a true routable address, 172.16.16.16. We also see a broadcast packet here, 255.255.255.255. All ones as a broadcast. In this basic example, we're going to combine a unicast and a broadcast packet to create a multicast packet. You'll notice the first 2 octets are a routable address. The last 2 octets are broadcast. Typical multicast addressing is done in the 224 to 239 range in the first octet. This can cause 2 possible problems if you're using multicast in your CCTV system. For the first issue, let's go back to layer 2. To an unmanaged layer 2 switch, a broadcast and a multicast packet look exactly the same. Thus, a layer 2 switch will treat a multicast packet of video just like a broadcast packet and broadcast that video to all clients on that segment of the network. If you're going to implement multicasting, you need a layer 2 switch managed that has the ability to do IGMP snooping version 2 or better. This allows the switch to tell the difference between a broadcast and a multicast packet. The second issue arises when we look a little closer at how multicast actually works. To receive multicast video, you need to be a member of the multicast group. Once this group is established, something on the network has to maintain the group. This is achieved via a multicast query, and classically, this is performed by a router. If you have an installation where you've enabled multicast and there are no routers and only layer 2 switches, the layer 2 switches can tell the difference between multicast and broadcast, but they can't manage the multicast group. This will result in network flooding and effectively shut your network down. The solution to this problem is a layer 3 switch capable of multicast queries. The switch needs to have a physical ASICs chip, that's an application-specific integrated circuits chip, and should have the functionality of either PEM sparse mode or dense mode, depending on what your vendor supports. The last layer of the OSI model that we're going to cover in this module is a transport layer. There are several things that happen at this layer that are critical for you to understand as they pertain to CCTV. The first of which are protocols, TCP and UDP. They both reside at the transport layer. TCP is a connection-oriented protocol that ensures reliable delivery of data. It's just like signature confirmation mail. Let's take a look at how TCP works. Here we see a sender and a receiver, and they have a negotiated window of 3. That means the sender will send 3 data packets, and then the receiver will send back an acknowledgement, as shown here. Once the sender receives his acknowledgement, he will attempt to send his next 3 packets. You'll notice we drop packet 5. So when the acknowledgement comes back from the receiver, the sender will attempt to resend that drop packet. Lastly, the receiver sends an acknowledgement stating that he got the last packet. On a small scale, this is an insignificant amount of overhead, but when you're dealing with 200 or 300 cameras in a CCTV system, you are adding in an enormous amount of overhead that's not needed. Most CCTV systems, for this reason, rely on UDP. UDP, or User Datagram Protocol, is a thin protocol. It doesn't have the bells and whistles of TCP. It doesn't have delivery confirmation, and it has far less overhead. This makes it ideal for CCTV applications of all kinds. The last issue we need to discuss at the transport layer are ports. There are 2 types of ports we're going to discuss, UDP ports and TCP ports, and they fall into 3 categories: common, registered, and dynamically assigned. Ports are like windows or small doorways that applications use to move up and down the communication stack. Ports range from port 1 to 65,535. Here we see some well-known TCP ports, TCP port 21, which is FTP, and TCP port 80, which is HTTP, the World Wide Web. Well-known ports range from 1 to 1023. Registered ports range from 1024 to 49,151, and dynamically assigned ports run from 49,152 to 65,535. Pictured here, we see UDP ports with a question mark. Typically in CCTV installations, video is transmitted in a UDP fashion. It's transmitted in the registered port range, and UDP ports are dynamic. That means depending on the application that you're running, the video that you transmit could be on any port between 1024 and 49,151. From a troubleshooting standpoint, if you are in an environment where they're doing port blocking, firewalls, or content filtering, this could affect your CCTV installation. Port usage depends on the product that you're using. It's different for DBOS, DVAR, BVMS, VRM, or VDOS. You will receive a port utilization chart at your certification class based on the product that you're going to install. You don't have to be a CCNA or a network geek to install IP CCTV systems, but you do have to have a basic understanding of how networks function and how it can affect your installation. Remember, a little bit of knowledge goes a long way when you're trying to troubleshoot a network. This concludes this module. Thank you.